We're now going to analyze the second derivative to determine if there are any points of inflection. Now, for here, I'm going to rewrite the original derivative, f of x equals 1 plus x squared over 1 minus x squared squared, so that we can better analyze the second derivative. The second derivative is super critical to calculate this correctly. So I'm going to take this fraction and I'm going to write it as 2x bracket 1 minus x squared squared minus 1 plus x squared to 1 minus x squared times negative 2x all over 1 minus x squared all squared. This is my quotient rule. Now I'm going to factor out my 2x, both the front and the back, giving me 1 minus x squared squared plus 1 plus x squared times 1 minus x squared all over 1 minus x squared, and this should be to the 4, sorry. Now we can factor out a 1 minus x squared out of the top and bottom. So this equals 2x, 1 minus x squared, 1 minus x squared plus 2 plus 2x squared, all over 1 minus x squared to the 4, which equals 2x times 3 plus x squared over 1 minus x squared to the 3. So my second derivative of x is equal to 2x 3 plus x squared over 1 minus x cubed 1 plus x cubed. F double prime of x equals 0 when x equals 0, and f double prime of x is undefined when x equals 1 or x equals minus 1. Okay. As 1 and minus 1 are not in the domain, they are not critical values or possible points of inflection. Possible locations for inflection points. As 0 is within the domain, it is a possible inflection point. To determine if it is an inflection point, I like to create a sign chart using the values -1, 0, 1, 2x, 3 plus x squared, 1 minus x cubed, 1 plus x cubed. Creating my sign chart, I'm positive, positive, negative, negative, positive everywhere for 3x plus 2, negative, positive, 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 negative. Multiplying by my signs, I get positive, negative, positive, negative. So I'm concave up, concave down, concave up, concave down. as the concavity changes about x equals 0, there is an inflection point at x equals 0. Now we are going to incorporate all of this into a nice sketch. Let's insert some space. In my sketch, I want to incorporate the fact that I have an asymptote at 1 and -1. I want to be, I have a point of inflection at f of 0, which is, or at x equals 0, which when we plug into the original function, plug 0 in, we get 0 over 1, which is 0. 1 minus 0 squared equals 0 over 1, which is 0. So I have a point of inflection at 0, 0. Okay, and now if we look at our sign chart, we are positive, negative, positive, negative. So positive, negative, positive, negative. I am increasing, decreasing, increasing, 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 increasing. Okay, and now I'm concave up, concave down, concave up, concave down. And I have my curve sketch with my point of inflection at 0, 0.